Hey, so let's start working on the problem of the day, missing and repeating. The problem says given an unsorted array ARR of positive integers, one number A from the set of 1 till n is missing and one number B occurs twice in the array. Find the numbers A and B. Okay, so a few things I mentioned there that we are going to be having natural numbers from 1 to n, but the sequence is going to be unsorted. Okay, one value would be missing from it and another value would be repeating. Okay, you can categorize those two values, assume it to be A or B. Let's suppose this sample case is given in which we have 2 comma 2. Simply we can see which value is repeating. Well, 2 is repeating and which value is missing. If we take the set from 1 till n here, 2 being the maximum number, that means 1 is missing, right? This 2 comma 1 or this answer is returned. Its repeating number is 2, smallest positive missing number is 1. Okay, now taking this example up, similar thing is going to happen, right? 1 3 3. Well, it should have been 1 2 3, correct? 3 is the repeating number and 2 is the missing one. Okay, now the question is being expected to be solved in order of n time complexity and order of 1 space complexity. Let's first discuss what could be the most easy or naive method to solve this. Well, it must be coming to everyone's head that why not just sort this array and compare the sequence with the indexes, right? Well, that would give you answer, but the time complexity once you sort an array, well, that is going to be order of n log n, correct? And then you do the comparison, that would again take order of n. Well, around it is going to be n log n only, but it is not what the question demands actually. Okay, so that means this approach should be kept aside. How can we approach this question in a better manner? Well, for that, let's discuss one more approach. Let me take up an example. Let's take 1 3 4 3 5. Okay, so assuming and just by seeing it, you know the answer that 2 is going to be the missing value and 3 is the repeating one, right? But how are we going to get till that point? Let's see. One approach could be that why not we create a corresponding array, right? In which we put up, let's say, Boolean values, right? So I'm going to put here false, false, false for every value, right? Now I will check for the supposed correct value in this sequence. Okay, if the value is present, I would turn it to true, right? Let's say I have 1. So what is the supposed correct value for the sequence and for the 1 in the sequence is? It should be the 0th index, right? 1 less, because this is the correct position for 1, 2, 3, 4, and 5 in this manner, right? So if let's say I'm traversing this array of mine and I found that, okay, 1 has occurred, what I'll do is I'll change this value to true. I went here. Okay, I got 3. That means the correct position is this one. I changed this to 3. Going to 4, I changed this to 4. Going to 3, now something happens. Once you try changing the value which is there, right, which is at the correct position of 3 in this Boolean array, you will see that the value is already true. You will now realize that 3 has occurred once more. So that means this is the point where you have found your already occurred element, correct? Keeping up with the traversal, you go to the next element. You go to the next element here, which is 5. You see that it is false and you convert it to true, correct? Now you have found which number was repeating. And you might have already guessed it, how we are going to find out which was missing. Well, we just need to take a look at the Boolean array. There is going to be one value which still would be false, and that is the supposed correct position for 2. Thus we know both of the values that we needed to send. Now can you tell me what still is a drawback with this approach? Although this is very efficient, it is being completed in order of n time complexity, but we do require this Boolean array, which is also order of n in terms of space, correct? Now we need to think of something smarter than this. What are we using this Boolean array for? Well, we are using it for marking, right? For marking the elements. If I can somehow omit that and try to mark in this array only, well, then that could be beneficial. I just need to stop using extra space, correct? So for that, I can play even smarter. What I'll do is, let me just clear this up and I'll show you. I know that index go like this. The indices go like this, correct? And the supposed correct positions are these. This is the actual array that I have in my question. I have to mark the elements, right? With the supposed right, with the position which is supposedly correct, which we were doing in the Boolean array. Instead of using the Boolean array, what I would use the negative symbol. So let's say I started traversing this array. I went to 1. Now I know that the value is 1. Well, what is the supposed correct position for 1? Well, it is 1, right? So I will simply mark a negative sign here. That means 1 has occurred, and at its correct position, I have put the negative symbol. The negative symbol is not anyhow affecting the magnitude of this number. We are just keeping it as a mark. Every time we need to obtain the value which is present here, we will just take the absolute value, right? Coming on to 3. Well, now when I encounter 3, the magnitude, the value, I know the correct position of 3 is going to be this one, correct? Where 3 actually would have seated. So at this position, I will put a negative symbol. Continuing the same approach, I'll go here at 4 and I'll see that which is the correct position for 4, this one. I will put a negative symbol here. Now I'll go to this value. Well, once I go here and I see that the magnitude of this value is 3, but when I go to check that the supposed correct position is this one, well, this already holds a negative sign. This already holds a negative sign. And now you know what is happening. It is similarly like when you are going to mark something true, but it is already true. So at that point, you know that, okay, this number is actually the one which is repeating. Okay, so we have now successfully found our repeating number. Continuing with the same example, I went here and I saw, okay, 5. What is the correct position for 5? Well, this one. I'll mark negative here. Okay, so once the traversal is ended, order of n, right? I have found the value which was repeating. Now it is very easy to guess which value is actually the one which is absent here. You just need to take a look again in this array, see at what position the negative value is not marked. The negative sign is not marked at this element, and this element is actually the supposed correct position for 2. That means 2 is the value which is missing. So this is how we are going to solve this question. We have found the missing value, we have found the repeated value, and we have found the missing value. Okay, and that too without using any extra space. We just took one iteration of order of n, and we slightly iterated a few steps more. You can say that, okay, it is going to be 2n, but still it would be considered order of n. All right, let's quickly see the code for it. Well, the code is mentioned here. You can see I'm preparing my answer list, which is going to be holding my my repeating number and my missing number. And here I will start my traversal. I will check that if the magnitude of the number, that means the value that I have in my actual array, and I'm considering the absolute value, that means negative is not considered. -1 is actually a number, right? That means once we have that, we are going to mark negative at its supposed correct position, which is going to be this, right? And this will keep on happening until we find that, okay, the number that we are going to mark negative is already negative. Then it will fall into the else category. And we have found our repeating number at that point. So we will put up the repeating number, correct? And this, like after this for loop has executed, our repeated number is with us, and we have to find the missing number. For that, we have to use one more iteration and have to check whichsoever number is actually positive and the negative symbol is not marked there. I have to take under the consideration which is the index there, or which is the index there. I have to do +1 to it to find the number, the supposed correct number there. And that is how I will find my missing number. Once my answer is built up, I'll simply return it. Okay. And then the time complexity is going to be order of n for this. You know, we are having just 2 iterations of it, and the space complexity is order of 1 because we are not using any extra space. Let's try running this code. Okay, so here we are. Let's compile and run it. It is giving us the right output. Let's try to submit that. And yes, it has passed all the test cases successfully. So I hope you have found this video helpful. If you did, then do like the video and drop your comment there. Thank you.